2 variable stats notes, day 4, and we're going to talk about goodness of fit. So an example of goodness of fit would be flipping a coin. If you flipped a coin 100 times, you would expect to get 50 heads and 50 tails. So maybe I did it in front of the class, or I gave you a coin. If you got 60-40, you'd be like, yeah, okay, that could happen. 70-30, no big deal. That's a little weird that you got so many heads. But you know that there might be a little bit of variation by chance, okay? Just from randomness. However, if you got 97 heads and 3 tails, at this point, that is just too weird. It could happen to chance, but not likely, okay? That'd be really rare to happen by chance. What if you got 100 heads? Even more rare. It could happen, but really, really rare. So that's the goodness of fit, is how well does what we're seeing fit what we expect to see. There are lots of goodness of fit tests, and one we're going to talk about is the chi-square. Chi-square actually has 3 tests, but we're going to use the goodness of fit, okay? And it's used to find if 2 classifications or factors from the same sample are independent, i.e., if the occurrence of one of them does not affect the occurrence of the other. So here are some examples that could include. Income and voting intention. We know that sometimes people that have more money might vote differently than people that have less money. Gender and money earning capacity. Okay. Do men still make more money than women? And in Utah, that is usually true. Okay, some more. Gender and occupation. Is there a relationship there? Do men tend to pick more science jobs or dangerous jobs? In the 60s, this might have had a bigger difference between the two than we do now, because women have more choice. I don't know. Or age and job. Do you tend to have, is there a relationship between how old you are and your job? Now, age and job, you have to be careful. This would have to be something like young, middle-aged, or old, because all of these are categorical, or we will make them into categories. And so we'll talk about that in a minute. Notice that we aren't doing how much you weigh like we did, and height like we did with linear. So here's my example of how this works. Okay, is favorite movie choice independent of gender? And the choices that we gave people were Mr. and Mrs. Smith, 300, and The Notebook. This is a really old survey. Okay, and actually, okay, and we went out and we asked people, you know, we wrote down our male or female, and we went out and asked them, which movie do you prefer the best? Mr. and Mrs. Smith, 300, or The Notebook? And of the men, 25 liked Mr. and Mrs. Smith, 80 liked 300, and 15 The Notebook. And then these are the results for the female. 30 liked Mr. and Mrs. Smith, 10 300, and 60 The Notebook. Okay, and the question is, if there was no relationship going on, is this similar to what we would expect to get? Or does a person's gender affect their movie choice? Okay, so the first thing you would do is add up all the totals. So 25 plus 80 plus 15 would give you 120. So there were 120 men surveyed. 30 plus 10 plus 60, there were 100 females surveyed. Key thing. Notice that these two numbers are not the same. Okay. As well as these. And these could have ended up the same. But we don't rig it. If we're looking at gender, we don't do 100 men and 100 females. You just go out and ask a population. If you rig it so that these two numbers are the same, you actually invalidate the test. So you just have to ask who's out there. Okay? And then we make some hypotheses like in science. Okay, and these are always the hypotheses you write down. Don't write down anything else. We have the null hypothesis, which is the base hypothesis, that movie choice and gender are independent. Boys and girls are likely to like the same movie regardless of gender. Okay, if we see any difference between these movies, it's just by chance. A boy is not more likely to like the action movies than The Notebook. Okay, that's our hypothesis. And it's always the hypothesis, even if you think it's something different. Okay, and then the alternate hypothesis, or the alternate hypothesis then, is that movie choice and gender are not independent. Okay, that doesn't mean that there is for sure an association, just that we have enough evidence to say that there's something going on. Okay, all right, So we're going to stop and do a little foray into probability theory. So in talking about probability, if events A and B are independent, then the probability of A and B happening at the same time is the probability of A times the probability of B. And I'm guessing you might need to change your notes and make this into a times. It's been a plus for a long time and I don't think I fixed it for you guys. Okay, so here's my example with the flipping of the coins. Okay, the probability of getting ahead, I think you would all agree, is 1/2. Okay, 1 out of 2. There's a head and a tail. So the probability of getting 2 heads, okay, flipping a coin and flipping it again or flipping 2 coins, is the probability of getting ahead times the probability of getting ahead, which is 1/2 times 1/2, or 1/4. And that means that if I flip a coin and the first time I get ahead, if I flip it again, getting ahead the first time is not going to affect what I got the second time. That's the definition of independence. There's no relationship there. Okay, so we use this idea to figure out what we would expect to get if there was no relationship. So here's the deal. We have Mr. and Mrs. Smith, okay? And I'm going to highlight stuff. You just write it down. I'm highlighting it so you can see what I'm writing. Let's look at this part first. The probability of being a male out of this whole survey is 120 out of 200. So let's go back here and see. Yes, we had 120 males that we surveyed. Not out of 200, or sorry, 120 out of a total of 220 people. So that's a probability of being a male. The probability of liking the movie Mr. and Mrs. Smith, well, that's 90 people out of 220. Okay. Okay, I hope you just caught the error. I said Mr. and Mrs. Smith. 90 is for 300. Okay. The probability of liking Mr. and Mrs. Smith was 55 out of the 220. Okay, 55 out of 220. And so if we use the formula then, the probability of being a male and, remember that's our intersection thing we've already studied, liking the movie Mr. and Mrs. Smith the best, is the probability of being male times probability of liking Mr. and Mrs. Smith. So 120 over 220 times 55 over 200. Now if you were going to simplify that, okay, well, if you did that, just ignore this green stuff for a minute, okay? Male times Mr. and Mrs. Smith, if you put it in your calculator, you'd get 3 out of 22, or 0.136, which is about 13.6%. That's what you would expect if there was no relationship, okay? Now, but there is a shortcut formula for that, and that's right here. And it's row total times column total over total total. And that is because we have 13.6% chance. But we want to know how many people out of the people we surveyed. So if we times that by 220, okay, again, if we times that by 220, we'd get about 30 people. So what that means is we would expect if there was no relationship between gender and movie preference, that if we went out and surveyed 220 people, okay, where 120 were men and 100 were female, that 30 men would prefer Mr. and Mrs. Smith. The shortcut for that is this row total times column total over total total. And that's because notice how we times by 220. If you times by 220, okay, the one denominator drops out, and that becomes, this is the row total. This was the number of men. This is the column total. This was the number of people like Mr. and Mrs. Smith. Notice again, row total times column total divided by total total. Okay, so that's our shortcut. And we will use a calculator to do this. But again, we do everything by hand first. So here we go. I went out and found my expected data. What would I expect? So I did that formula for everything. For number of men, there were 120 men. Times 55 people like Mr. and Mrs. Smith. Divided by the total number of people. That's 29.9. Normally you don't round. And you'd go out as many decimal places as possible. For this example, I'm going to round. But if you were to do it in your IA, you don't. Okay? So we would do that for all of them. Let's just go over this one. This would be that there were 120 men. 90 people total that liked the movie 300 divided by 220, and we'd get 49.09. So we would expect 49 people to be men that like 300. So these are our expected values. This is what we would expect if no association. And I guess I should say expect if independent. If we went out and surveyed this many people with this makeup of male and female, we would expect to get 49 men that like the movie 300. That's assuming there is no relationship between the gender and the type of movie you like, which we all kind of know is not true. So this is rigged. Okay. I'm going to pause here and give you another version in a minute.